Today we're going to be working on how to solve inequalities. So the first thing I want you to put into your journal is this inequality right here, and we're going to go over some quick little inequalities as a review. All right, I'll go back to that. So what I'd like you to start out with when you're dealing with inequalities, all right? So what is an inequality? Well, hopefully when we think of unequal, you mean not equal. So we have different symbols like greater than, less than, greater than or equal to, less than or equal to. So I'm going to write some statements here. All right, so here's a quick little review before we start solving inequalities. This means x is greater than 2. So in your journal you might want to write x is greater than 2. Now how would you graph that on a number line? Like how would you graph that if you had to graph it on a number line? So we'll go over 2 spaces this way. This is -2. So if x is greater than 2, that means it has to be a number that's actually greater than 2. So it can't include the 2. So I have to put an open circle. Now that open means not equal to. Okay, that's not equal. But if I wanted to have everything greater than the 2, then that means everything over here is going to be shaded. So if my set of numbers is all real numbers that are greater than a 2, then I know my arrow is going to be pointing, all the numbers are going to be going to the right. Now interestingly enough, if you read this, x is greater than 2, look what's happening when the arrow is pointing. It's going to the right. All right, so the next one, x is less than 2. That's what that means. X is less than 2. So what would that graph on a number line look like? There's your 0, there's your 1, there's your 2, there's your -1, and I'll just put -2 right there. There's your -2. So once again, I cannot include that number, so I have to put an open circle, so I can't include it. But all the numbers that are less than 2 are technically to the left, going to the left. So you just make a nice shaded arrow going to the left. Okay, so make it nice and shaded so everybody knows, hey, all the numbers that are less than 2 are going to the left. You'll notice, if you read it, x is less than 2. Look where the symbol is pointing also. Look where it's pointing. It's pointing to the left. So how do we denote whether something is equal? Well, there's that equal to symbol right there. All right, so this is x is greater than. So that's the first part. That's the greater than. Or we say it's equal to the number 2. So how do we graph it's greater than or equal to 2? Well, we'll do that next. And this would be x is less than or equal to 2. So we're going to graph those. And whenever you're graphing these next two on a number line, if you're ever having to include the number, so there's our 0, here's 2, there's 1, there's -1, -2. There we go. So if I have to include the number, that means I have to put a solid closed-in dot. I got to close it in. That means it's including it. So that means equal to. So that means equal to. Technically, right there, I would say if I wanted to graph x equals 2, that's what I would graph right there on the number line. Okay? But ours was what is greater than or equal to. So what do I have to do? I got to shade everything to the right. Shading everything to the right. That's not a very good arrow. Hopefully you can draw a better arrow than me. All right. I'm sure you can. Over here, if I say x is less than or equal to 2, then I got to do the solid dot, which means equal to, but I got to shade everything to the left. So making sure you go in that direction. All right. So that's less than or equal to. This is greater than or equal to. Look, interestingly enough, look, it points to the left, all right, just like the symbol kind of points to the right. So it's greater than or equal to, less than or equal to. So those are the four. Those are the only ones you got to worry about. There's only 4 of them, okay? All right, if somebody says there's something as a greater than or less than sign, like this is greater than and less than, it's not going to work. It's got to be greater than or less than. It can't be both of them. So on this one, what we're going to do is the first thing you got to do is you got to distribute. So I'm going to rewrite this a little bit bigger so you can see. So I got 5 parentheses 2 minus x close parentheses less than negative 2x plus 6. So we treat this inequality sign right here. We treat this inequality sign like an equal sign. We kind of treat it. So whenever we move numbers across, we're still going to be adding or subtracting those numbers, just like when we were solving equations. So we got 5 times 2, which is 10, and 5 times negative x, which is negative 5x, is less than negative 2x. So we still use the distributive property first. The order of operations, they do matter. But then you have to ask yourself, where do I have the most x's? That says negative 5x. That says negative 2x. Well, technically, negative 2 is greater than that. So what I'm going to do is I'm going to add 5x to this side, and I'm going to add 5x to this side. Now these will zero out, but this becomes a 3x. Now I'm just going to bring down this inequality symbol right there, bringing it down. There's that less than symbol. Then you got to say, wait a second, if I move all my variables to the right, that means I need to move all my constants over to the left. So I'm going to take away a 6. These are additive inverses. Whatever I do to one side, I have to do to the other side. And 10 minus 6 is 4. So here's what I have. I've got 4 plus a 0 and 3x plus a 0. Well, that only leaves me with 4 is less than 3x. So what's my final step? Just to divide both sides by 3. So that leaves me with 4/3 is less than x, because 3 divided by 3 is 1. Now, you're not going to see this answer on a multiple choice test. You'll most likely see x is greater than 4/3. So you got to learn how to take this and kind of rotate it. Like, notice the mouth is opening up towards the x. So if you wanted to think of it as like Pac-Man, all right, you could think of it as Pac-Man. If it looks like this, well, guess what? That mouth better be opening up towards the x, that greater than symbol. Okay, so that's going to be your final answer. Now, how could maybe a calculator help you, or it could help you solve for the x, but it's not going to help you with the greater than. So take a look at this. So we got a couple of things. We got Desmos test mode, and we have regular Desmos. Well, regular Desmos would actually solve things for you if you wanted to check your answer. So let's see here. What did we have? We had, let me look. We had 5 parentheses. Okay, so if I had 5 parentheses 2 minus x, all right, and then I close the parentheses, and I put the inequality, and the inequality symbol was less than, so I make it less than. And then I just type in negative 2x plus 6, negative 2x plus 6. You can kind of see that the only area that's shaded is all the area that's greater than this 1.3 repeating. Just so you know, 1.3 repeating is 4/3. And if you type it in long enough, you can change it to a fraction right there. You can see that it's 4/3. So my x value is greater than 4/3. Well, that's regular Desmos. That kind of lets you know if you got an answer right or wrong. But if you're taking a test, you can't just take that and type in the exact same thing and it work. All right, so you can't do 5 parentheses 2 minus x and then put an inequality symbol and put, what was it, negative 2x? Yeah, negative 2x plus 6. All right, you'll see right here it says plotting inequality is disabled for a test. So you can't do that. But here's what you could do. You could graph this and graph this, see where the two lines meet, okay? And there's that 1.3 repeating, so you could see you could actually solve for the x value, but you actually have to figure out whether or not it's going to be greater than or less than. That's going to be something you're going to have to figure out on your own. That's why we want to make sure you know how to solve it on your own. All right, let's go ahead and move on to the next problem real quick. Let's go down here. This won't take too long. The rest of this, it won't take too long. As long as you follow along with me, it should be pretty easy. We're going to talk about how to translate this. It says 12 less than 5 times a number is greater than, or equal to, all right, 6 more than twice the number. So we're going to translate this. Now, 12 less than 5 times a number is actually written as 5x minus 12. And if you're like, wait a second, I thought it was going to be 12 minus 5x. Well, 12 minus 5x is 12 less 5 times a number. That's how you write 12 minus 5x. That's 12 less 5 times a number, but this says less than. So think of it this way. If I said, what's 1 less than 10? Well, 1 less than 10 is 9. So if I say 1 less than 10, in your head you're doing, okay, 1 less than it, which is a 9. You're not going to say 1 minus a 10, which is a negative 9. You're not going to say that. So be very, very mindful that less than means you're taking that number 12 less, you're taking it away from whatever you have. Now it says or greater than or equal to, so I'll put greater than or equal to. And the last one says 6 more than twice a number. 6 more than twice a number. So I'm just going to write this down over here. Got 5x minus 12 is greater than or equal to 6 plus 2x right there. And now we're just going to solve for, x. That's all we're going to do, just solve for it. So we got more x's on the left-hand side than the right-hand side. So what I'm going to do is I'm going to take away a 2x on this side. Whatever I do to one side of the inequality sign, I got to do on the other side. Got 5x minus 2x, which is 3x. If I move all my variables to the left-hand side, I got to move all my constants to the right-hand side. So how do I get rid of a negative 12? You just add 12. That's it. Whatever you do to one side, you got to do to the other side to keep things in balance. Maybe not in your life, but hopefully in this math problem. Okay. So we have 3x is greater than or equal to 18. So all I got to do is divide both sides by 3, and we get x is greater than or equal to 6, which happens to be answer choice C. All right. So what was the purpose of this problem? To help you guys take words and translate them into an inequality so that you can solve it, and then you can see the correct graph that goes with it. Okay. Just so you know, this answer right here would just be x equals negative 2. All the other graphs are correct, but that is not a correct graph, so make sure I cross that off. All right, a couple more to go and we're done. Let's take a look at number 7. All right, I'm going to rewrite number 7. We got negative 3 parentheses x plus 4 minus 8x is greater than 21. All right, so we're going to go ahead and solve this guy. First thing you got to do is distribute. You got negative 3x minus 12 minus 8x is greater than 21. Got to combine some like terms here. We're going to combine this negative 3x and this negative 8x. Got to combine them. All right, how do we combine them? Just add them together. You get negative 11x minus 12 is greater than 21. All right, next step, we got to isolate the variable. We have all the variables on one side, so all I'm going to do is just going to add a 12 to this side. Add a 12 to this side to get all the constants to the other side. So I have 33. Let's bring down that symbol. Okay, now I have negative 11x. So all I did was just bring down the symbol. But this is where I wanted you to see what's going to happen, because we are going to divide both sides by negative 11. And we're not just dividing by an 11, we're dividing by a negative 11. And what happens whenever you divide or multiply an inequality by a negative, the sign will flip. So that greater than sign now becomes a less than. So our final answer is x is less than negative 3, which end up being answer choice F in this particular case. All right. So this is important that you need to write down, all right? So you know what, I'm going to type it. I'm going to type it, but probably be faster than me writing it, okay? So I'm going to type in whenever you multiply, gotta spell it correctly, or divide an inequality by a negative, the sign, the inequality sign, will flip, exclamation point, exclamation point. It will flip. So make sure you understand that that's what's happening right here. Whenever you, not when you multiply or divide, but by a keyword, I'm going to put negative. I'm going to try to, maybe I can highlight it, okay? By a negative. So because we divided the side by a negative, the sign had to flip. So make sure you write that down in your journal if you're taking notes. If you're not taking notes, well, you'll probably forget it, and you'll get it wrong later in life, and you'll wish you did. All right, so here's our last one. We're going to distribute to both numbers. All right, here's our last one. So when I distribute to both numbers, and you can pause the video, write it down, and then catch back up. So go ahead and pause, write it down, distribute. You get 6x minus 3 is less than 8 plus 6x. Now, here's the last scenario that could possibly happen. Well, actually, technically there's two scenarios, but this is one of the last two. Look what happens when I take away 6x from both sides. That zeroes out. That zeroes out. And all I'm left with is negative 3 is less than 8. What? All the variables are gone. So you have to ask yourself, is this a true statement? Is negative 3 less than 8? That is a true statement. If it's a true statement, then the answer is all real numbers. That would be the answer. All real numbers. Okay? So, all real numbers. Now, what happens if you get a false statement? Like, what happens if all the variables disappear and you get a false statement? Like, 5 is greater than negative 4. Well, 5 is definitely not greater than negative 4. What happens if you get a totally false statement? Then the answer is no solution. Also known as a null set. It looks like a 0 with a slash through it. It's a null set, like, or an empty set. I'm going to put empty. An empty set, or it's null. So that's what would happen if you get a false statement. If you get a true statement, the answer is all real numbers. Sometimes it's signified by this, the set of all x values such that x is an element of the real numbers. That's set builder notation. Sometimes they just put a set bracket and they put a capital R. Sometimes they write the word all real numbers. All right. Sometimes in interval notation, it goes from negative infinity to positive infinity. These all mean the same thing. And if you're wondering why I'm talking fast, well, I got to go to golf practice, and that's where I'm going to be going. So if you need to rewatch this, you're more than welcome to, or not. But you need to know how to solve for inequalities, and you need to know how to graph them. Have a wonderful day and life if I don't see you.